Today we're going to continue our first module, the introductions of shelf life of processed foods. We're going to talk on the part 3, the shelf life determinations. Before we talk on this part 3, let's do some recap. In part 1, we have known the shelf life definitions. We have shared on the 3 main considerations of food shelf life, which are safety of the food, the quality part, and the label declarations on the packaging. And there are 4 factors that affecting shelf life: the food formulations, the food processing, the packaging systems, and the storage conditions. So in part 2, we have talked on the shelf life dating, the various types of the examples we have shared according to the Malaysia food regulations, according to the US market requirement. Today's sharing, we're going to talk on the part 3, shelf life determinations. Let's have a look on what is the learning outcomes you're going to get in this sharing. So these are the learning outcomes. So the first one, we're going to know the basic approaches to determine the shelf life. In this part, we're going to learn the various types of methods to determine the shelf life. Then we're going to introduce the definitions of the ASLT, the Accelerated Shelf Life Testings, the benefits, then the unwelcome matters in shelf life determinations, uncontrollable issues, the resources that require for shelf life determinations, and the types of shelf life determination in product development. Last but not the least, we're going to talk on the shelf life testing strategy at different product development stages. There are various types of approaches to determine shelf life. First one, experience and the published literature. So a lot of experienced manufacturers will say, don't worry, you just follow the market leaders. If their products is put 6 months, we also follow 6 months. But do remember, there's a special case in the part 1 that we have discussed on the bread. You can refer back what is happening if it just based on experience and the published literature. Then we're going to have the direct determinations, which involve the extended ambient storage studies under recommended storage conditions, or the direct determination. Very simple, just put the product there and see what is happening on the products. Then we have some special tests called microbial challenge testings, we will discuss later. It's the same thing on the predictive microbiology, survival methods and the cutoff point, mathematical modeling, real-time and accelerated shelf life testings. So from the microbial challenging testings to the accelerated shelf life testings, we're going to talk more detail later. And the last one is the open shelf life storage test. So let's start. One of the very famous shelf life determination tests is a microbial challenge testing. So what is that? Actually, we are inoculating food with one or more relevant microorganisms to see what can happen during the processing, distributions, and or subsequent handling. So for examples, we're going to do the challenge studies with pathogens. Then the growth of the pathogens is being observed. Let's say we're going to inoculate the PEG studies of a low acid canned products by using Clostridium sporangiens spores. So normally we're going to use the spoilage microorganisms during the challenge studies. So actually the effects that caused by the study's parameters are the only things that being analyzed. But the multiple factors that face at the same time is not addressed. What means that? Let's say, okay, the storage conditions of the study products is in the ambient temperature. Thus, the other temperature, let's say during the food distribution change, in Malaysia the weather is so hot, so the temperature may rises to about 35 or 40 degrees Celsius on the food products. Terrible high temperatures. What will happen? So the effects caused by the study parameters is only refer to the micro. We don't include, let's say, the browning effects, the sensory changes, and other things. This is one of the shortage of this method. And then it is expensive, time consuming, and technically demanding. We need to employ a microbiologist to do it, or you need to send it to a accredited laboratory to do this type of microbial challenging testings. So the second method is a predictive microbiology. From the name, we know that we're going to predict the different microbial responses to the varying environmental conditions. You see that these predictive microbiology methods can accompany the microbiology challenging testing. It is fulfill the shortage of the above method. So what we do with this method? We're going to predict through the mathematical and statistical models. But we observe in the synthetic culture media. Okay? We're going to select the most influential factors and model their effects. But sometimes we may not know there are synergistic effects on other factors which may not be included in this method. So to predict the behavior of the microorganisms in the product, and you're going to interpolate. Remember, it's interpolate the resulting microbial proliferations of the combinations of the factors of the study. It's interpolate, it's not extrapolate. We only can predict what has happened in the range of study. So the predictive microbiology actually is widely used when we develop a new product. But there are some limitations.
Nani?
And its major limitation is what? As you can see, the pictures on your left hand side is a chicken kill. Okay? It sounds tasty, correct or not? Looks tasty, sounds tasty. But do you know, actually the ingredients to make these products is from the global sources of food. You have the herbs butter from Ireland, and the garlic puree from China, USA or Spain. Then you have garlic salt from China, USA or Spain. Then you have lemon from US, the parsley from France or UK, the pepper from India, water from Ireland, oh my goodness. Then they have chicken breast that may come from Ireland, Belgium, UK or Thailand. Then you may have the batter, the flour from Belgium, France, the water from Ireland, and the breadcrumbs from Ireland and UK, the rapeseed oil from European country or Australia. How are we going to predict in these conditions, the sources is from the whole world. Then another major limitation is it implies greater complexity for the manufacturers, especially for the small and medium food companies. The food manufacturers will not know what is this. It's an equation. But normally, we're going to make it become a graph, easier understand by the food manufacturers. But the result is correspond to a simulations, which may not be accurate because it's just a prediction that consider the major factors. Then we have a survival method or cut-off point method. It based on the opinions of the consumer or trained panelists about the physical qualities or characteristics of the products. So by knowing the attitudes of the people towards the same product with different dates of manufacture, we can determine if they would consume it or not. Or this is called the cut-off point method. They're going to establish a relationship between the shelf life and the perceived quality, especially the sensory and the chemical qualities of the products. But obviously, it do not accurately estimate the shelf life. It just gives a range. And we just can be used to establish the best buy date of a product. Then we have another method. It's called mathematical modeling. Oh my goodness. These are the sorption isotherm models that we use to predict the water activity in the products. Oh my goodness. Do you got fainted? Let's have a little bit in-depth explanations on these moisture sorption isotherms models. So normally we need to prepare an experimental setup, which may have the first one, the thermostatic basin or a cabin. We can control the temperature. Then we're going to have a jar. We need to have a sample holder. Then the product is held by the sample holder. And then you may have sulfuric acid solutions, or you may have different types of the salt. Then all the product is being put according to the different concentration of the sulfuric acid in the jar, and then we keep it for a period of times. Then the fitting results of the experimental data, let's say on tomato, okay, we're going to mark it down, and then you try to fit it to the various models that I have shown you on the last slide. And this is the moisture sorption isotherms of the tomatoes, published by Merriam and Marbrook at 2015, in the year of 2015. The figures A is the desorptions and the figure B is the absorptions of the moisture. So the first things, we need to choose the best model, okay, to see which models can fit in the most based on the highest coefficient of the determinations R square and the lowest chi-square. Okay, so you need to learn on the statistical knowledge. Then we're going to predict and extend the shelf life of our products by finding the critical water activity values, where the physical changes like caking, clumping, and the loss of the textures, the loss of the crispiness, which may occur. So it's just a simple explanation. So we're going to talk in depth in the later parts of this workshop. Then we're going to have accelerated shelf life testings. From the name, you know that it is totally different. It's going to use a shorter period of time. Okay, so we're going to evaluate or predict the product stabilities in a shorter period of time than the product's actual shelf life under the recommended storage conditions. So we can consider various types of factors which we're going to accelerate the deteriorative reactions. We can study the main factors, or we can combine it like storage conditions which involve temperature, the moisture contents, and the oxygens. But normally we're going to apply it to the foods that have longer shelf life, at least several months. Let's say if we're going to have products like cultured milk, which only have shelf life about 2 weeks, so there are no point we're going to do this accelerated shelf life testing on it. The key assumption is the deteriorative process or mechanism limiting shelf life will remain the same under both recommended and the accelerated storage conditions. So we need to keep it in our mind. This is a very important hypothesis that we have made. So since this is a workshop of accelerated shelf life studies, so we're going to talk in the later parts. Let's go direct into their benefits. First one, everybody will know that we reduce the shelf life testing time. Okay, so we can do many tests with the minimum delays, especially when we want to introduce or launch new products into the market, or we want to extend the shelf life of existing products through the changes in formulation, processing, or packaging. After glance through various types of methods in the shelf life determinations, actually there are some unwelcome methods in all these methods. Let's have a look. The first one, the laboratory samples is different in the pilot plant, and for sure it's also different in the commercial products. The main difference actually is the homogeneity of the ingredients in the products. Then the second one is the errors in the analytical or sensory evaluations. It can be due to the human errors or the apparatus errors. Then the third thing that we may get headache is how to select and train the sensory panelists. Then the problems in asking panelists to taste a spoiled product. I don't think all the panelists is willing to taste it, but some of them is good. They know what are their responsibles. The last one, there is a variability of the ingredients, process, and the product throughout the years of the production of a food product. It is difficult to achieve a targeted and reproducible shelf life because the ingredients, the food process, and the product may vary. There are also some uncontrollable issues in ASLT. The first one, you see, when we're going to do comparisons, we need to have a control samples. Actually, there are some difficulty in preparing unchanged controls which require in some tests. Let's say freezing. Normally, we're going to get the frozen products to compare with the accelerated products. But do you know that freezing may cause some irreversible structural changes? Let's say in some high fat content products, freezing may cause oxidations. Happens more rapidly. But in another way, if you want to prepare some fresh control for each test, it will be very costly and the effects may vary. Do remember in the last slide we said the ingredients, the process, it varies, it changes all the times. These small changes may give significant defect is in uncontrollable issues. The second, use of the rate enhancing factors may accelerate other deteriorative reactions which become predominant. Let's say we're going to use temperature, we increase the rate of deteriorations. We think that when we increase the temperature, the oxidations may happen faster, but we don't know until a limit or until a point, the Browning reaction may overtake the oxidative reactions and it become more dominant in the higher temperature conditions. Then third, use of accelerative factors can cause changes. We're going to invalidate the ASLT results. The last one, do remember a valid kinetic model for a particular deterioration process may not be known. Although there are a lot of uncontrollable issues and some problems may arise during the shelf life determination, but we still need to do it. So the resources that are required for shelf life determination is very important. The first one is a human factor. The appropriate human resources with the relevant technical knowledge and competency is the most important consideration or most important factors. Then, for sure, we need to have adequate tools and facilities. Nobody can cook without the cooking apparatus. Then, there is a very important factor that we need to consider is the commitment of the management. Okay, then we need to have an appropriate management system too. So, normally the boss will say, can the shelf life determination be outsourced? We don't want to take care of all these uncontrollable issues. Can or not? Can. Yes. But it would be ultimately be more cost effective to have a basic in-house capability. Remember, it'll be more cost effective because every batch of the food products we need to do shelf life determinations. You just imagine how much cost you need to invest if you do it outsourced. So there are various types of shelf life determinations throughout the product development stages. So according to the IFST UK, which published in 1993, there are 4 stages. The first one, the initial shelf life studies is being done during the product concept stages. You're going to provide us the indication of the probable mechanisms of deteriorations. Then, we need to do the preliminary shelf life determinations during the lab or pilot development stages. The provisional shelf life is to be included in the draft product, process, and packaging specifications. Then we have the confirmatory shelf life determinations during the full scale of factory batch or product launch. And do remember, only for the long life products, we're going to use ASLT or experience. Okay. And the last one, for the routine shelf life determinations, is going for the ongoing surveillance. It being conducted during the normal productions, and sometimes the revisions of the shelf life is being required. These are the four main types. So let's continue. According to Fu and Labuza in 1995, they suggested different types of shelf life testing strategies at different product development stages. First stage, during the product concept, we need to get the general stability info. Then, during the product development stages, we can do challenge study, like the microbial challenge study. Then, in the pilot line testing and the scale-up line trial, the accelerated shelf life testing is in. Because we need to get a fast result. We can't wait. Then, during the full line productions, we need to do the confirmatory storage study. And for sure, in the marketplace, we're going to have ongoing shelf life monitoring. After going through the whole introductions of the food shelf life determinations, normally we're going to ask ourselves a question. Can the shelf life of my food product be extended? I don't want just predict the shelf life or determine the shelf life. I want to extend my shelf life of my food product. Can it be done? Probably. If we're going to consider to optimize the shelf life of the food products through the first one, reformulate our food products, which involve the ingredients, the preservation methods. Then we need to redesign the process of a productions. The last but not the least, we need to consider the packaging system that we use. But for sure, this is another story which are not included in this workshop. We may have another one. So in a summary of the whole module, what do you think is the best definition of the shelf life? For myself, I just want to give a recommendations to all the manufacturers. We must take into serious considerations on the consumer unacceptability. And do remember the case for the instant noodle that being sold in Korean market and the China mainland market that we have discussed in the first part. You may go back and refer. Second, do you know the difference between expiry date and the date of minimum durability? Which one is more appropriate to be used? We need to choose wisely by consider who is our targeted group or who is our targeted consumer and the category of our food product. Who is responsible for the shelf life determinations? For sure, is the food management. Very important. They need to have the commitment to pay their responsible for the shelf life of determinations. And the last one, at this moment in time, have you got adequate resources to conduct in-house shelf life testings? We are going to welcome you to continue our workshop in a closed group conditions. We're going to send you another video clips to talk about it. So that's all for today. Hope everybody is in a good day and wish you all the best. See you in the further sharings on the accelerated shelf life testings in a closed group. See you there. Bye.